This is Algebra 1, Lesson 6.5, Linear Inequalities. Picking up with part number 2 on example 3. Didn't quite get to the rest of it yesterday. Example number 3 says sketch the graph of 2x plus 3y is less than 6. So look how it tells you to solve it. Instead of having less than, it says to go ahead and graph it as if it's an equal sign. That's the easiest way to do it. So all you do with that part right there is change that inequality to an equals. That way you can change it and make it into slope-intercept form. Now this form already, this standard form, 2x plus 3y equals 6, is in a nice, neat form that we could graph using intercepts, but it's not always going to be nice and neat. Oftentimes when you try to graph standard form, you'll have to estimate where the intercepts, the x and y intercepts are, because you'll get fractions. Now 2 and 3 both go into the number 6, so you could use the intercepts, but the reason we're changing it to the slope-intercept form is because most of the time it'll be tough to do that. So take 2x plus 3y equals 6 and make it say slope-intercept form. Make it say y equals mx plus b. We know how to move everything over in order to get y by itself. So the first thing you want to do is move the plus 2x or the positive 2x over by subtracting 2x. Notice when it went from the left side to the right side on this line here, it became negative 2x because you can't take it away from 6 because they're not like terms. So then you have 3y equals negative 2x plus 6. In order to get y by itself, at that step, you divide by 3. If you divide that by 3, make sure to divide everything on the other side by 3. And you'll have negative 2 divided by 3, or negative 2/3 x, plus 6 divided by 3 is 2. Now this is in mx plus b form. We know how to graph this. This is the first way we learned how to graph after simply plugging in values for x and then plotting individual points and connecting the dots. B tells you where to begin. Your B value is 2. It's positive. So that means your y-intercept tells you the graph to begin at 2. So at 2 is at this point right here. Don't worry about the dashed or solid line yet until it's time to actually draw the line. I know it's on there. Don't worry about it just yet. The next part is the y-intercept. That was the y-intercept. The next part is the slope itself. Remember, that's what's multiplying by x. That's your m value. It's negative 2/3. Remember, if you keep the negative at the top in this case, you're always going to go down instead of having to go left if you have a negative value. So from that point 2, you go down 1, 2, because it's negative 2, and to the right 3 times, 1, 2, 3, and you put your second point. Once you have 2 points, look back at the original inequality to determine if it's going to be a solid line or a dashed line. Remember, if it's not or equal to, it's going to be dashed. So I know this picture's already drawn. So make sure you create a dashed line. Then you're going to need to shade one side or the other. Now, the picture is already shaded for us, but let's talk about how we decide which side to shade. We're either going to shade everything this way or everything that way. Remember, it's not one or the other. We're separating them into half planes. One side's right, one side's wrong. It doesn't pass through, the line itself doesn't pass through 0, 0. That's the easiest thing to test. That's why it says the origin 0, 0 is a solution. The way we can determine if it's a solution or not is we can look back at the original inequality. In place of this right here, plug in 0 for x, and you get 2 times 0. Plus, plug in 0 for y, 3 times 0. Now, this isn't something you need to write. That's the reason, that's the beauty part of using 0. Because we know that when we multiply anything times 0, we get 0. Plus, again, anything times 0. So you wind up with 0 is less than 6. Check to see if that is true or false. It is true. The big mouth is eating the bigger number 6 in that case. So you shade towards, again, not left, not right, not up, not down. You shade towards 0, 0, since it was a true statement. You see how it says the graph is all points below the line? There are times when your line gets steeper that below and above won't make sense to you. There's times when your line gets flatter, when it's more horizontal versus more vertical, that it won't make sense to say left or right. So be careful right here with below the line. Again, it's relatively easy to see in this case because you can tell, yeah, that's definitely below the line, but it's harder to see when your line is steeper versus being more flat. Towards the number or away from it is easier to understand. Okay, sketch this one. X minus y is less than or equal to 2. Remember, there's two distinct differences. Is it solid or dashed? And then shade the correct way. Take about a minute to do this one. Okay, let's take a look at this one. X minus y is less than or equal to 2. Make it say y equals mx plus b so you can graph it. Again, you can graph it in standard form using intercepts. Most people don't feel as comfortable with that method. So what you want to do is you want to take that x minus y is equal to, notice I wrote equal instead of less than or equal to. We'll go back to the inequality after. And you want to move the x over. It's positive on the left. So you know how to undo that plus x by subtracting it. If you subtract it, when you subtract it on the right-hand side, you're left with negative y on the left equals negative x positive 2 or plus 2. Notice how I wrote it that way to make it say mx first. Not quite y equals mx plus b though. It says negative 1 times y. We know how to undo that. We undo that times by dividing by negative 1. If you do it there, do it here and do it here. Make sure you divide everything by negative 1. A negative 1 divided by a negative 1 on the right gives you a positive 1x, and then a positive 2 divided by negative 1 is a negative 2. So y equals, here's your equation in mx plus b form, y equals x minus 2. That's not the equation we're graphing though. We're graphing the inequality. Y, now you have to determine with this, do I reverse the inequality symbol or not? This is why we did this last week. Take a look at each step. Does this make us reverse the inequality by subtracting x? No, only multiplying or dividing by a negative number. That says less than or equal to. Therefore, on the next line, it's going to remain less than or equal to. What about this step? It says divide by negative 1. Does that make us reverse them? Yes. When you multiply or divide by a negative number, you reverse that symbol. And instead of saying less than or equal to, now it says y is greater than or equal to x minus 2. So when we graph that equation, y is greater than or equal to x minus 2, our b value is negative 2. So that means to begin on your y-axis at negative 2 right there. Your M value is the one that's not shown. Remember, slopes, are always fractions. So if it's an integer, make sure you put it over 1. That tells you to go up 1 since it's positive and go right 1 again since it's positive. So up 1 and to the right 1 will put your second point right there. Now you had to determine, do I make a solid line or a dashed line? Nothing about converting your equation or your inequality changes it from the fact that it says or equal to. It's either going to say or equal to at that point or not. Even if it reverses and becomes greater than like we made, it still says greater than or equal to. That's what determines if your line is solid or dashed. Since it is or equal to, we know that our line is a solid line, hopefully straighter than what I drew, a solid line through those 2 points. Again, it's not simply an equation. It's an equation shaded on one side or the other because it's separating into 2 half planes. Again, either shading everything this way or everything that way. Don't shade it messy like that. Remember, we can determine which way to shade by checking to see if we can plug in 0, 0. The line doesn't pass through it. The only times you can't use that is if it passes right through it. So we're good right there. Plug in 0. Go back to this inequality right here. Plug in 0 for y. 0 is greater than or equal to, plug in 0 for x, minus 2. 0 is greater than or equal to negative 2. True or false is what you have to determine. The big mouth is eating the bigger number. 0 is bigger than negative 2. So you shade towards 0, 0. And that's what your picture should look like. Again, if your line is going down the other way, that means your slope, you forgot to change your slope when you divided a negative by a negative to make it positive. If your line has dashes in it, you didn't realize that it said or equal to. And if you're shading the opposite way, make sure that you plugged in 0, 0 and got a true statement to shade towards 0, 0. 2 checkpoint problems. X plus y is greater than or equal to negative 2. Make this slope-intercept form by subtracting x. This one's a little simpler than the one we just did because there's only one step to it. You don't have to divide by a negative number at all. So y, negative x minus 2. All we did was subtract x. So you don't reverse the inequality symbol. It says y is greater than or equal to negative x minus 2. When you graph the inequality, it's going to go through the b value, negative 2. So on your y-axis at negative 1, 2 is where your first point's going to go. That's where you begin. Your m value is the number that's not shown, negative 1. So your m is negative 1. Remember, it's always a fraction, so put it over 1 if there's nothing there. That means to go down 1 and to the right 1. So from that point that we already have, where we began, we're going to go down 1 and to the right 1 for our second point. We have 2 points. Now determine if your line is solid or dashed. It says or equal to. That's the determinant in that. So you make a solid line since it says or equal to. Just try to do it a little straight. I'm having problems drawing straight lines. Your line should look like that. We're sketching these graphs anyways. Now we're going to shade everything this way or everything that way. We determine which one it is by plugging in any point. 0, 0 is the easiest thing to multiply. That's why we use 0, 0. When we plug those values in, 0 is greater than or equal to negative 0 is still 0. Doesn't matter that there's a negative in front of it. Minus 2, 0 is greater than or equal to negative 2. Again, check its truth value. 0 is the bigger number that the mouse is eating, so you're going to shade towards 0, 0. There is your inequality graph. Number 4 says 5x minus y is less than 3. Move it to where it says y equals mx plus b. That's what we're trying to get. So the first thing you want to do is you want to move 5x over by subtracting it since it's positive 5x. If you do it to the left, subtract 5x on the right. That leaves you with negative y on the left, negative 5x, positive 3. Notice I reordered the right-hand side. Do I have to reverse the inequality symbol or leave it alone? based on the fact that we subtracted 5x. Leave it alone. We did not multiply or divide by a negative number. Now it says negative 1y. So that means negative 1 times y. You undo that times by dividing by negative 1. If you divide that term, make sure you do it to everything on the other side. Remember, you add and subtract like terms only, but you multiply and divide everything. So y, negative 1 divided by negative 1 is going to cancel out and leave you with y. Negative 5 divided by negative 1, a negative divided by negative is going to be a positive 5x. And then positive 3 divided by negative 1 is negative 3. At this step, however, unlike the first step, now we're dividing by a negative number. So we're going to take that symbol less than and reverse it to make it say greater than. This is the inequality that we can graph. Y is greater than 5x minus 3. So when we graph that inequality, our b value is negative 3. So we're going to begin at negative 1, 2, 3 at that point right there. Our m value is 5. Remember, 5, your slopes are always fractions. It's positive 5. It tells you to go up 5 and go to the right 1 time. So 1, 2, 3, 4, 5, and to the right 1 time for your second point. Now you have 2 points. If it were just an equation, you'd draw a straight line through it and be done. You have to determine if you draw a straight line or a dashed line. Remember, this is what makes the difference, this right here. Does it say or equal to or not? No, it doesn't. Since it doesn't say or equal to, that means we're not counting the line, and we're going to draw a dashed line through those 2 points. It's still a straight line, but it's dashed. That means not to count it. Again, we're going to shade everything here or everything here, one or the other. We're going to determine, since our line doesn't go through 0, 0, we're going to pick that point 0, 0 and plug it into our inequality. We're going to plug it in right here. 0 is greater than or equal to 5 times 0. Again, you don't even have to write that out because you know 5 times 0 or anything times 0 is going to be 0. So you can say 0 is greater than or equal to 0 minus 3. So 0 minus 3, 0 is greater than or equal to negative 3. Check the truth value of that statement. Is 0 greater than or equal to negative 3? Is the big mouth eating a big number is the question. Yes, it is. So you shade towards 0, 0, and that's what your graph should look like. Yeah, purple, okay. Okay, it was pointed out a second ago that on my greater than, oh no, it's purple writing out here, I said or equal to. It's not, everybody, it's just greater than. But everything else holds true. The line is dashed, and it is greater than, so you're shading towards 0, 0.